Hello friends, welcome to part 2 of our Machine Learning the Future course. We are looking into part 2 regression. As already looked into various types of machine learning regression models, there are simple linear regression, multiple linear regression, polynomial regression, decision tree, SVR and random forest regression. So we have already looked into what exactly is simple linear regression. Y is equals to m0 plus m1 into x1, where y is the dependent variable, m0 constant, coefficient and the independent variable. We already seen the actual working, what exactly is simple linear regression and how is the simple linear regressor model which has been identified. So there have been multiple lines which has been drawn, and the sum of the squares of the distances and the minimum of those value will be taken as our regressor line. So this is our simple linear regressor. So let's begin the machine learning practicals. For our machine learning practicals, we'll obviously be using Anaconda, in which we have already launched our spider program. As in our previous module, data pre-processing model, we have already stated that before starting with the actual machine learning model or building the actual machine learning model, we will obviously have to manipulate our data, which is using data pre-processing model. So first of all, let's set our working directory. So for this module, for our simple linear regression, let's set our working directory. So this is our working directory. As you already seen, this is our data set, which consists of experience and the salary, out of which the experience is the independent variable and salary is our dependent variable. So let's start our simple linear regressor model. So first of all, we'll use our data pre-processing template to fine-tune our data or to pre-process our data. So let's copy it out. So let's copy our data pre-processing template and let's paste it over here. So first step is importing the libraries. So let's execute those steps. So let's execute. So it has been executed. Our next step is importing the data set. So be careful what is the name of our CSV file. So here the name of our CSV file is data underscore salary underscore experience dot CSV. So regarding the values over here, now x is equals to data set, I location, everything, all the values except the last one, obviously, because the data set, if you look at the data set, the minus one or the last column is the salary, which will be our dependent variable. So this will be x, which is our independent matrix of features, so that will constitute of only one column, which is experience. Now y will constitute of only one column, and that column number will be the value 1. So this is our data set. Let's execute this. Yeah, so it has been properly executed. Now next step is taking care of missing data, but in our data set there is no missing data, so we'll obviously remove this statement. Now categorical data, as you already know the data set over here, there is no categorical data in our data set, so we can obviously remove this part of statement as well. So our next step is splitting the data into training set and test set. So from the scikit library we have imported the train test split, and we have already stated what we need to perform. Now in this scenario we have mentioned the test size as 0.2, which was from our previous model. So what will be our test size in this case? So what will be the amount of data in the training set and what will be the amount of data in the test set? So what are the number of columns, or now total number of entries are 30. So we can actually split up into 1/3. So we can actually see 1/3 will be our test size, and our random state is 0. So this will be as it is now. Let's execute this. Yes, so it's properly executed. So now you can see there are various variables which are involved here: xtest, xtrain, your data set, your matrix of features, your vector of dependent variables, ytrain, xtrain, so our next step is feature scaling. Now with respect to the feature scaling, most of the libraries of our machine learning model will take care of the feature scaling if there is any kind of feature scaling required in our data set. So for simple linear regression model development, there is no requirement of feature scaling which is to be done using our code. So we can actually comment this out. So that's it. So we have implemented the data preprocessing template on our simple linear regression model. So let's develop the simple linear regression model after this. So now the data has been presented, or the data preprocessing template has been executed. So the steps which needs to be performed prior to the development of any kind of model is ready. So let's perform the simple linear regression model. So for that we'll move on to the next part in the next video. For this, thank you very much. Bye bye.